Welcome. Welcome to module on files. Welcome to module on files. In this, first we'll start with introduction to files. What exactly file is and what are the devices? What are the devices that can be used to store the files? And why we have to create files, store files, that we will discuss. If you consider the memory, we have discussed that memory can be divided into two types. Memory can be broadly divided into two types. One is main memory, the other one is secondary memory. Main memory, secondary memory. Apart from it, there are also other kinds of memory like cache memory, pen drives, etc. So, but broadly, memory can be divided into two types. Main memory and then secondary memory. So, the main memory is actually RAM. Random access memory. Main memory is RAM, random access memory, which is a temporary storage. It is volatile. And its contents are lost when the power goes off. Whereas if we consider the secondary memory, example of secondary memory that is generally used is hard disk. Hard disk is a permanent storage device. That means its contents are not lost when the power goes off. In many situations, we require data and programs be stored in persistent storage medium. Persistent means the one whose contents are not lost. So, example is this hard disk. Now, how the data or programs are stored on the hard disk? Okay, we require permanent storage. We want to store something permanently. But how? How is it possible? In what form they are stored? So they are stored in the form of files. So it is actually the files that are stored on the persistent storage medium like hard disk, and it is the files which are permanent. Except in rare cases where there is a hard disk crash, etc. Okay. So if something unexpected happens, if you lose the hard disk, then it's a different issue. So the data or files on the hard disk is stored. The data is stored in the form of files. Programs are also stored in the form of files. So it is the files which are permanent. If we consider file, what is the definition of the file? The file is a logical abstraction defined by its creator. What does it mean? A file is a logical abstraction defined by its creator. So defined by its creator, that means what is stored in the file. What is stored in the file is decided by its creator. That means the programmer or the user of the file is going to define what you want to store. In the file you can store C program. You can just simply store the data. Okay. Say the addresses of different persons can be stored, that can be treated as data, and then different things can be stored in a file. Say image can be stored, video can be stored, all are stored on the hard disk in the form of the file, but its contents are defined by its creator. What is stored on the file is decided by its creator. That is the main important thing. Why files? From the programmer perspective. Data and programs need to be permanent. Why? What is the reason? So if we consider writing the programs, whenever you write the programs, and your program will make use of some data. So if the data items are say 5 data items or 10 data items, then you can type the data items. So whenever you run the program, that program actually asks for the input. If you have 5 data items to be supplied, then you can type them using the keyboard. And your program uses them, and it may produce the output. Maybe it again produces say 1 data item or 5 data items or 10 data items. So the values of those data items are displayed on the screen. So everything is fine. But imagine you write a program where you have to manipulate the contents of a file, and that file contains the information related to 1,000 students. Can you imagine typing the information of all 1,000 students using the keyboard? It's a huge task. Not that it is impossible, but it's a huge task. Similarly, whenever the data is displayed, if you print this students' data, 1,000 records, then they don't fit on the screen. You have to scroll. We can display it, no problem. But it's difficult for you to view it. And particularly analyze it. So usually whenever there is a large amount of data, then you will go with analysis of the data. So that is required. So when you have small amount of data as input or output, you can go with standard input device, keyboard, and standard output device, monitor. But whenever you have large amount of data, go with the files. Moreover, different sets of programs may access the same file and process it or analyze it in different ways. It's not one program which has to access the data. The same data may be accessed by different programs. Suppose you wrote different programs, like say one program to calculate the attendance, the other program to calculate the say marks of a student, maybe the other program which decides whether the student is eligible for scholarship or not. All these programs may access the same data stored in a file. So that means assume that file contains all the data related to a student. Then all these programs will actually access the same file. Same file. So sometimes the data itself may be permanent and stored permanently. So you want the data to be stored permanently. For example, backup. So you have to keep the backup. That's very, very good practice. Sometimes you want to transfer the data. How do you transfer the data? Usually the data is transferred from one computer to another computer, using files. It is the files that are transferred. So coming to the different types of files. There are different ways of classifying. So a file may contain say C program. In that case it is called as source file. A file may contain data, say student data, name of the student, roll number, marks, etc. So list of students. So in that case you call it as a data file. Audio file, like MP3 file, the data may be in the binary form, but still if you use appropriate player like MP3 player, Windows Media Player, etc., you can play that. So video files contain video related information, object files and executable files. So whenever you compile the source file, you get initially object file. Object file is considered as true translation of the source file. True translation, that means makki ki makki antam kada. Makki ki makki. So object file is true translation of the source file. So after linking all these library functions, etc., you get what is called as executable file. Executable file, you can take it anywhere and run it directly. So, but we are more interested in the broad classification, classifying into test file and binary file. So test file which contains test data, in the sense that you can open the file and view the content of that file. it will be in the test form. Whereas in the case of binary form, the data is stored in terms of ones and zeros, but you don't see actually ones and zeros. If you open it, you see some garbage which you cannot understand. But binary file contains data, say we'll assume in the form of ones and zeros, which you cannot view with the text editor. So it will not be, you cannot read it. But the content can be played by appropriate player like Windows Media Player. Okay. Now how to interpret the files, that is beyond our scope. So every file contains actually, in the case of image file, video files, etc., header part will be there, body part will be there within the file. So using the header information, the body part will be processed. But that is beyond our scope. So operating system support for files. Do the operating system really support files? Of course, they support files. But do they differentiate between the files? If you consider Unix and Linux, they don't differentiate between the files in the sense that they don't use any extension. You may use it, but they don't recognize it. You may use it, but they don't recognize it. Okay. They treat every file as a sequence of bytes. Whereas if you take Microsoft Windows, it supports NTFS and FAT. They are actually called as file systems. Every operating system supports file system. So it is, in the case of Windows, Microsoft Windows, it is NTFS, New Technology File System, and FAT, File Allocation Table. Whereas Linux variants support ext2, ext3 and ext4. This is Unix. Unix uses UFS, Unix file system. So different operating systems, including say Android, uses their own file systems. So you have to, if you want to process the files, actually you should understand the file system that is supported by that operating system on which you are working. So as we discussed it, in case of C language, we are interested in two types of files, test files and binary files. In the case of test files, the data is in the form of characters or text, whereas in the case of binary files, data is in terms of ones and zeros, which is machine readable, not human readable. If you consider the test files, they are human readable, whereas if you consider the binary files, they are machine readable. So next we will discuss different file handling functions. So we will only discuss the file handling functions in this session. Programming part we will do at the end. At the end of the module. File handling functions in C language. The first one is opening the file. So if you have a file, so whatever it be, test file or image file, whatever it be, so what you have to do is you have to open the file. Remember, you can process binary files also, though you cannot view the content, but still you can process them. You should know about the header part, and then based on it you will be processing. Okay, so that's what these media players do. Okay, but anyhow, whatever may be the case, you have to first open the file. So this is the function for opening the file. fopen. You have to supply the file name. And then mode. The mode. You have to supply the file name and then the mode of operation. So file name, as usual, is a name. That means it's a user defined identifier. There are different modes of operation. We will discuss in the next session different modes of operation for both test files and binary files. But for the time being, mode means whether you want to read the file, write the file, or whether you want to read and write to the file. They are defined. So how they are defined means the C language has its own method of defining. Every language has its own method of defining. So by using some symbols it defines, say R stands for read, W stands for write, etc. Okay, so that we will see later. But mode means what you want to do with the file. Basically, what you want to do with the file. You want to read, you want to write, or both read and write. You want to append, etc. So F open opens the file. F open opens the file. If opening the file is successful, then it returns what is called as file pointer. It returns a file pointer. If it fails, it returns null. So whenever you open a file using F open, you have to check whether you are successful or not. If it is null, you are not successful. Otherwise, it returns a file pointer. That file pointer has to be stored actually. Whatever it returns, that has to be stored. That has to be stored in what is called as a file type of object. We will see how to create a file type of object. So in simple terms, file star FP, file space star FP, file space star FP, file star FP. So like this you can define. So this FP should be on the left hand side. FP equal to F open of dash dash dash. So in that case, if the file opening is successful, you got file pointer. That is important because you will be making use of the file pointer in all the remaining functions. That means you have to first open a file before you do anything. Before you do anything, you open a file. Closing the file. So you have to close the file after use. Though it is not mandatory, it's better you do it. So close a file. Again you can see here the parameter is file pointer. So one which is written by the F open. So close that file. On success it returns 0. On error it returns U. Returns U. Next, fgetS. fgetS program. fgetS function. So fgetS is used to read a string from a file. We are not actually discussed what exactly is the string, but you can, for the time being, you can assume that string is nothing but a sequence of characters. So a line of text. So using fgetS, you can read a string from a file. So that means, suppose if a file consists of number of lines of data, then every time you invoke fgetS, one line is read. So whenever you want to read one line at a time, then you go with the fgetS. So size represents the number of characters to be read. It reads size minus 1 characters or up to a new line character. So this you have to remember, or at least you keep a note of it. Whenever you are doing the programming. But maybe from the exam point of view, exam point of view, you probably, or maybe in lab point of view also, you have to remember. These things you remember by practice. But it's better you keep a note of them. While doing normal programs in your lab, because it is little difficult, it is little confusing. By practice you may get it, but each and everything you may not remember. So you can say it returns one new line at a time. Okay, which one is encountered first? Say if the size is 5, then it reads 4 characters. So before those 4 characters, if new line is encountered, that means you have to, while giving the input, you have pressed the new enter. So if that is the case, then it will terminate. Otherwise, it will read up to size minus 1 characters. So here it returns the string pointed to by string. It returns the string pointed to by string. So the string is written. It also returns it. fputs similar to fgetS, but it is for transferring the string to the file. Transferring the string to the file. Copies null terminated string. That we'll discuss later. Null terminated string. Null is nothing but /0. Null is nothing but /0. It copies the null terminated string. So usually in case of C language, so every string terminates with this null character. So it doesn't append a new line character. If you want new line character to be appended, you have to explicitly place /n while transferring the data. So fputs is to transfer the string to a file. Next, fprintf, similar to the printf, but it deals with the files. So it transfers the values of these parameters to this file pointer. But according to the format defined here, it transfers the values of the parameters to this file according to the format that is specified here. So like %d, %f, etc. Whenever you want to deal with the formatted input and output and also files, then you have to use this fprintf and also fscanf. So maybe file of records of a student. In that case, you have to use fprintf and fscanf. When the data is just normally in the text form, so then you can go with the fgetS, fputs. But whenever the data is in the form of records, you go with fprintf and fscanf. You can read one character at a time and also transfer to the file one character. So using fgetC and fputC. fgetC gets one character at a time. Returns the ASCII code of the character read. fgetC. fputC is to transfer one character to the file. Next, fseek. It is for positioning within the file. Okay, fseek. It moves the file pointer to a specified position. In what way? So if you consider a file will have say beginning. A file will have end, begin and end, and maybe the file the file pointer is at this position, some position. So you have beginning, and then you can say it is seek set. Seek end is the end of the file, and seek cursor is the current location. So they are the predefined constants. You have to use them as it is. They are the predefined constants. So the position can be indicated by these three constants. In this place, you can write either seek end, seek set, or seek cursor. And relative to this one, offset. That is, offset refers to the displacement. Displacement with respect to the beginning of the file or end of the file or to the current position within the file. So you will be moving to that position, new position. You will be moving to that move position. There are other commands also like ftell, which returns the current file position with respect to the starting of the file. So these things you may use rarely. Similarly, the rewind repositions the file to the beginning of the file. So these are some of the file handling functions. So fopen, fclose we will use in every program related to the files, and if you may use fscanf, fprintf if you want to deal with the file of records, fscanf and fprintf. If you want to deal with individual characters, then fgetC, fputC can be used. If you want to read a sequence of characters or one line at a time, then you can go with fgetS and fputs. Those things is better you remember. So this is the reference which you can go through. So have a nice day. Best of luck. Thank you.